Now welcome back to my channel. So today I'll be going through PSLE 2023 question number 39. So this part of the question is really on electricity and drawing of circuits. Electricity, okay, drawing circuits, okay, that will match the observation statements. Okay, so can I set up an electrical circuit in a toy using identical bulbs and battery as shown? All of the components are all working. Okay, so let's take a look over here. Okay, you got batteries, okay, two of them, a fixed metal plate, okay, and notice that there's a gap over here. There's a gap. So electricity probably will flow through in here. Okay, over here, then here. Okay, this is probably how electricity will flow through. Okay, then okay, the light bulb is connected in this way. Okay, we have two light bulbs and one switch. Okay, so two battery, two light bulb, one switch. So get a sense of how the circuit is like first. Okay, when I close the switch, light bulb never light up. Okay, obviously light bulb never light up because there's so many mistakes. Okay, the tip, only the tip is being connected. The battery, if you take a look over here, this is the negative sign, this is the positive sign. So this is also negative, this is also positive. So can you see the negative is connected to negative in this way. So over here the battery is connected in the wrong way. Okay, the tip is also connected in the wrong way. So there's two mistakes. Okay, when you use a pencils to complete the circuit below, correct the mistakes. So two mistakes. Okay, the bulb must be tip plus casing. Okay, then the battery must be positive to negative. Okay, the battery must be connected in from positive to negative. So in this case, we must flip one of the battery around. Okay, change battery. Okay, change battery around. Okay, change one battery around, just one. Okay, they connect the bulb such that if one blow, the other one still light up. So in this case, they are trying to tell you that I must connect it in such a way, right? There's more than one path for electricity to flow through. Okay, parallel. Okay, parallel. So the light will only light up only when the switch is closed. So they are trying to tell you that the switch controls both bulbs. Okay, I need to make sure that it is beside battery. Okay, beside batteries. Okay, so in this case, it's kind of beside the battery based on the diagram that's given. So over here, okay, before we do anything, okay, so decide on the number of parts. So we got okay, we got two batteries, okay, two light bulb, okay, and one switch. Okay, so over here, same thing. Okay, all parallels, they are all make up a very mini smaller series circuit. So what you can do is that in this case, right, you can see the location of the light bulb is kind of fixed. Okay, so you probably want to deal with one of the light bulb first. I would say I'll deal with this because this one is at the edge. It's a bit difficult for us to adjust the light bulb that's on the edge, because at the back of my eye, our circuit should look something like this: battery, switch beside it, okay, light bulb, okay, and another light bulb. So it should look, at least minimally, it should look something like this. Okay, to make sure that this whole thing works. But the light bulb is very fixed location, so we have to change it accordingly. So before that, I'll like to give you a few tips. Okay, the light bulb must be connected in parallel. So when one bulb blows, the other one still light up parallel. The circuit must be connected in such a way, right, when the switch is closed, right, there isn't any gap. Okay? So that means all the components, there should not be any gaps between the parts. Okay? Check for short circuit. So in this case, there should not be one path, right, where there's no component that's connected with it. Okay? The wire must be connected and casing. The switch must be connected in series with the battery. Okay, so these are things that you should take note. Okay, so first up, we deal with the battery first. The battery is the one that is the most easiest. So maybe for the battery, I will draw it with black color. Okay, maybe I'll draw it in this way: positive, okay, negative. Okay, so okay, make sure that okay, there is no gap. Okay, that's how I already draw one gap. Okay, so that I close out any possible gap. So in this case, positive, negative. So electricity flow through here, then it will flow through here, then it will come back here as negative again. Okay, so pretty accurate. So I'm going to deal with this bug first. Okay, I'm going to draw a series circuit using one bug. So first thing first, I can do this. Okay, maybe I connect it this way. Okay, this way. Okay. Then after that, right, we will look for connecting points in the circuit, right, to connect it such as parallel. So in this case, right, do you realize that for me to add this section of it, right, I always add it after the switch, somewhere here, and then after the first bulb. Okay, so we must add it somewhere after the first switch. Somewhere from here to here sounds a little bit more logical. Okay, somewhere after the first bulb. Okay, after the first part means from here to here, all the way this part. Okay, which makes sense. Okay, so I'm going to remove all the crosses. Okay, so I'm going to draw two connecting points, this and maybe somewhere here. Okay, so that it makes more sense. Okay, so I'm going to draw using blue color. Okay, casing. Okay, I will not connect it here. I will not connect it here. I must connect it in such a way that it is after the bulb. Okay, maybe somewhere here. Sounds a bit more logical. Okay, so in this case, this is how the electricity is going to flow through. Okay, I'm going to check if it's work based on the condition. Okay, so let me remove the circle first. So over here, the electricity is going to flow through the red color path. Okay, from positive. Okay, this way. Okay, then the blue color path, it will take it in this manner. Okay, go through the switch, pass through the light bulb, go through here. Okay, connected. Okay, so now we check. Okay, when one bulb fills, right, the other one still light up. So let's say this bulb fills. Okay, no longer working. So the blue color path will not exist. Okay, so I remove the blue color path. Can you see the red color path still there? So in this case, it works based on this statement. Okay, so now I check for the red color path. Okay, so when the red color path disappear, the blue color path still work. Okay, so in this case, I fulfill the requirement. Okay, the first requirement. Okay, so the light bulb only light up when the switch is closed. So let me focus on here. So when the switch is closed, right, both paths should be allowing electricity flow through. So when the switch is open, both paths should not allow electricity flow through. So now I open this switch. Can you see both paths disappear? So in this case, this should be the correct answer. Okay, it fulfills two conditions, and I can check again. Is it to tip to casing? Yes. Is it tip to casing? Yes. So this is correct. Did I connect positive to negative? Yes. And the other side, is it positive? It flows through, and negative? Yes. So these are correct answer. So in this case, right, this should be the type of circuit that we should be drawing. And in this case, if you want, you can remove the positive and negative sign. So it's more for you to know that how the battery should be allocated. So this is actually a perfect example how you should be able to draw a circuit that fit into this scenario. So this is the correct answer. So let me show you some not so good examples, so you know what not to draw and what to draw. Okay, so let me show you this part. Okay, these are the wrong example. So in this case, this person, right, connect the tip to casing, so the light bulb is connected properly. Okay, the battery is also connected properly. Okay, so everything looks perfect, but the circuit did not match. Okay, so in this case, if you take a look, the electricity maybe flow through this path. Okay, then it flow through a red color path, right? Can you see if this bulb fails, right, then both light bulb will not work. Okay, both light bulb will not work, so the circuit connection is wrong. Okay, so this one, why wrong? Okay, wrong circuit connection. Okay, does not fulfill the observation statement. Okay, so this one same case. Okay, it actually it is probably due to the flow of electricity. So the battery drawn correctly. The battery drawn correctly. Okay, they are correct. The light bulb, tip and casing, they are all correct. So this one, they will award marks for you. So let me show you this part. Okay, electricity flow through this part, maybe for the blue color one. Okay, flow through here, maybe for here. And then the red color path. Okay, can you see that this light bulb, it control both electricity flow. So when this light bulb fuse, both also fuse. So in this case, right, what can be done to really save this portion? Okay, so maybe I take out the red color one. Okay, so how to really save this part, right? What you can do, maybe this line, right? Don't connect here. Don't connect here. This one after the switch ready, right? So you connect this part after the bulb. Okay, so what you can do, you take this out, you put it here. You put it here straight away is correct. So let me check. Okay, straight away is correct. Okay, go through here. Okay, up. Okay, up, right? Yeah, for this part. Okay, so then this will be correct because over here this light bulb only has the blue color electricity. This light bulb only has the red color electricity. So this one, if she rectify it this way, right, this one will be the correct answer. Okay, so this part same thing. Okay, the green color is a correction. So you can see this part is a mistake. The light bulb properly did not connected properly. The battery also did not flip and did not reverse it. Okay, so that one is not a good example. Okay, this one is what I mean, that the light bulb isn't even connected. So this one straight away is wrong. Okay, did not even connect the light bulb properly. Okay, and the wire did not even touch the light bulb. So how to rectify this? Okay, so this part, right? Okay, this part I'll do something like this. Okay, I'll cross this part. Maybe I'll put it here. Okay, so I have to put, okay, can you see this part after the switch, right, is correct? So I put this up after the light bulb. Okay, this part straight away it should be correct already. Okay, so that means I don't connect here. So let me the battery is drawn correctly. Okay, let me try to show you how the electricity flow through. Okay, electricity will flow through this part. Okay, another part I did not rectify it. Okay, tip ready, right? Cross. Okay, cross. Yeah, over here. Okay, this part I ignore it. Okay, the light bulb is not drawn correctly. Okay, so let me just show you this part. Okay, go down, light bulb, go down here. Okay, then the blue color path. Okay, same thing from this battery, go down. Okay, the blue color path, go up. Over here, connect. Okay, this one is the correct answer already. Okay, if this person remove certain lines, over here this will be a correct answer. The circuit connection can be saved. This one can be saved one. Okay, can be saved. Okay, you just need to know the key rule. After the switch, after the bulb, you draw the connection in. Then you should probably you should more or less have a very parallel circuit that can control two electricity pathway with, and each bulb will have one electricity pathway. So when one bulb fuse, the other bulb will not light up. So let's check. Okay, so you can see the switch, right, over here connected to path, right? So when the switch is open, both electricity pathway will not be flowing through the circuit. So when the red color light bulb fuse, okay, only the blue color light bulb will light up. Okay, so when the blue color light bulb fuse, only the red color light bulb will light up. So this is one way that you can kind of save it. So this one become from a wrong answer, you can become a correct answer. Okay, so over here, okay, this part is also another way that actually I save save the students. Okay, obviously the battery is connected wrong way. It should be in this way, then it should be correct. Okay, so let's go through this part. Okay, the main portion that I draw, let me draw in blue color. Okay, over here. Okay, tip casing, connect here. Okay, then the other pathway, the red color path. Okay, connected the casing, then tip. Okay, this part don't go up, don't connect here. Go up, connect here. So then this one will be the correct answer. This part is actually how you can save the circuit. So you just erase a few more lines. Okay, for the last wrong example, this part a bit hard to save lah, because when you draw something like this, the wire is around the light bulb, is really technically very hard to save. But the battery drawn correctly. This part also drawn correctly. It's just that this bulb is really drawn wrongly. So this part just redraw this part. Okay, this is the correct example. Okay, so far this is a correct example. So battery is correct. After the switch, after the second wire is connected after the bulb. So you can see that the electricity flow through this part, the blue color part. Okay, the blue color part. Okay, over here, then the red color part. Over here. Okay, so when the switch is open, both electricity will not flow through. Okay, so when the light bulb blue color is fused, the red color, right, it should be continuously in this way. It still will work. Okay, so okay, the red color, let me just draw it. Okay, so when the red color fuse, okay, the blue one will still work. Okay, let me just try this part. The red color fuse, the blue one can still continue to work. Okay, so you can see this part. This is actually a circuit that fulfill the correct condition. Okay, so this part is more or less correct. So I've gone through a several example. What is the correct drawing? What is not so correct? And how can you actually save and rectify it along this manner. So let me just go through this part, okay, to this page, so you can take a look at the final answer, how to really draw this part. And for the last tip, right, is that right, some students, they will do something like this. They will connect this part over here. Okay, they will do this. They will connect a wire over here. Okay, once you connect a wire over here, it's also straight away wrong. This one will become a short circuit. Okay, what will happen? Electricity will just flow through this pathway. Okay, around it. Okay, this is what we call a short circuit. And then no electricity will flow through the red and blue color pathway. Okay, so don't go and draw one line over here. Okay, this whole thing become a short circuit. Okay, so don't do that. Okay, if not, that will become a correct answer. It will become a wrong answer. So this part don't add a line in over here. Okay, so with that, okay, let me just zoom out. With that, we are more or less done with this question. Thank you very much.